Hey guys, so welcome to High Entropy. It's day 85 of DSA learning, and to be honest, I'm really sorry if anyone is gonna watch this video. And the reason is simple why I'm saying sorry, and the reason is like I'm not following any particular timing consistently, like when I need to upload videos or when I need to stream, when I need to solve the DSA problems. I'm just randomly solving at any time when I feel like okay now I should start. Sometime I feel so I'm consistent but not disciplined, you can say. So here you can say what's the difference between consistent and disciplined. So when it comes to consistency, it's not about like you are doing something every day, but when you are disciplined, that means you are following particular time, particular routine, and you are doing the activities. So still I'm not disciplined. I'm consistent, like I'm solving problems every day. Yesterday also, I think on video I haven't solved, but after that I solved the problem. Oh god, what happened? I thought I lost my streak. Yeah, so yesterday I solved the problem, and I took lot of time to solve this problem because it was just it this problem blown my mind, to be honest. It was the one of the hardest problems I have observed, and MCM, matrix chain multiplication, is a really difficult topic for me. I would really say it's so far this is the difficult topic. I feel like to understand, to come up with solution, and every problem is little different, and you will feel like oh problem is not intuitive how to solve it. And yeah, so I felt the same. It was difficult to analyze, difficult to come up with solution, and I was not able to solve it by just learning the MCM. I have to go through the video. Still, I was not able to solve. Then I watched another video. Maybe I'll show you. There is another tutor. So I watched her video, and then I got intuition more, like what is happening. So here was Kirti, I don't know, Kirti. Yeah, so I watched her video related to this, and she once okay. So I watched till when she was telling, she was explaining the concept, but then she directly jumped to the 2D, like how to solve it using matrix. Then I thought okay, now I need to solve it using DP, and then I will try to convert it in not DP. I need to solve it using what we say. Oh man, I forget the things very quickly. So first I decided okay, I will solve it using recursion, simple recursion. Then I will try to memorize it, and it was simple step. Just you need to create an array and pass it I and j, and then I decided okay, now I can jump into the 2D DP and iterative method. You can say bottom up manner. And MCM DP is also little complex, but I mean it's new, and you have to come up with like a different approach as compared to the previous one. Were so intuitive. Like you were, if you solved one problem, in the second problem you can get intuition. But here it is little challenging, and yeah, it's a good thing. Like it's challenging, but yeah, you will enjoy it. So let's jump to another problem. I think it's the solved one. I don't know why it's not showing. Yeah, so it's already been solved, and now I can jump into the. Okay, did I transition? Yeah, it's a transition. So we can jump. So next problem is different ways to evaluate a Boolean expression. Okay, Boolean expression. You are given a string expression consisting of the character T, F, and or and XOR. Okay, represents true, false, and logical and operator or operator. I'm so bad at expression is guaranteed to follow the pattern operand operator operand operator operand. What the Okay, pattern follows pattern operand, then operator, then operand, then operator, operand, operator. Oh, okay, got it. Either it always starts and ends with operand, with an operand, and no two operators are adjacent. Okay, so it means it's like a binary operators. Operators are between the operands. Example: true or false. And so, what is the goal of this one? Number of distinct ways to fully parenthesize expression such that the whole expression evaluates to true. Oh, okay, got it. A goal is to simply the result of the expression should be true because the answer can be very large. Return it to modulo 10 to the power 9 plus 7. Okay, just I'm wondering what is the XOR. Oh, I forgot the jar. Let me just recall it. Exclusive R, right? True, false, and what are the operations? Operands, and or, and jar, and or, and jar. So I know and is okay, or is okay, jar. Jar is exclusive, right? I mean, yeah, jar is like when both are equal then zero, other opposite then true. So true and true result will true, uh, false false, and true false false true. So it will be something like true true zero, I mean false, and if both are equal, if these are opposite then true. Okay, let me cross verify it once. XOR in Boolean algebra, Boolean table. Okay, 0 0 0 0 1 1 1 0 1 and 1 1 0. Opposite then it will be true. Okay, perfect, got it. Now we have true. Let's do it. Okay, so this is one operation. One of the it sounds like it's similar to the previous problem, not very similar to the previous one, I would say. You have options to pick one operator you want to perform operation on which operand you want operand you not operator you want to perform. So let's say you are performing on this operand, you are picking this one first. Then what are the different options you have? You will pick this one and you will pick this one, and you will evaluate what is the value of it, and whatever the value that you get, now you have another option. Okay, so okay, now suppose you are looking for this one, you want to perform the operation on this one. So what you will say? Okay, no problem, just evaluate this one, and whatever you are getting from this, and whatever you are getting from this side, and return me, and I will evaluate this, and it will be result of it. Or you can pick any other operator. Let's say you pick this one, and then you will say okay, now just give me the result for this and this, and then I will tell you what is the what would be the final result. It seems like it's a simple compared to the previous one. I feel so. Let's not judge it quickly. Where are you? Okay, so here. Oh, no, 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 it's not that one. Yeah, so what I feel, suppose there are some operators, you have option to choose an operator out of these operators. So operators will lie at the I plus 1, I plus 2, I plus 3, not 3, I plus 5. For example, here if we talk about indexes, then it will be this true. It's a kind of 0, 1, 2, 3, 4, 5, 6. So if you know, it's like here we have I will start with 1 and j will be total length minus 1, n minus 1. Okay, now whenever we are picking an I no, what are the options, like when you are checking, so k can be between I to j, and it will be k plus equals to 2. So for example, it could be 1 in this example, or it could be 3, or it could be 5. So let's say you took 1. Okay, so whatever the I value that you are picking, right, k value that you are picking, that means you need to find the solution for the because this operation depends on these two. So you need to find the solution for okay, I and k. K is the operator, so last operator before it will be k minus 2, and here you will say k, it will be k plus 2, 1, 2, next operator, and j. So these are the two things, and you will see okay if you are getting any result from it or not. And suppose you already exhausted all the operators and there are no, so you can return true. That is one option scenario, right? So let's take example in this one. Let's try run for this. True or t and f XOR t or t and f XOR t. So we have different options, right? So let's say I have k between 1 and 3. Okay, so let's first note down the index 0, 1, 2, 3, 4, 5, 6. These are the string index, right? So yeah, so okay, k can be, you can say okay, one thing just notice, I be between 1 and, so first I is, okay, let's do one thing, I will follow the proper approach, otherwise it will be like messy to follow up. I equals to 1 here, and j equals to n minus 1, correct, and n is 6 here, so 6 minus 1, 5, sorry, n is 7, length is total 7, so n minus 2 will be the index. So 7 minus 2, 5, j 5. So when I and j are 5, then what is the range for k? K can be between I and j, and increment will be plus 2. Okay, so value of k can be uh, 1, 3 and 5. So let's say we took 1, so we are looking for 1. So actually when we are taking 1, so there are three options. Okay, if we are taking k1, then what are the options? You will say, okay, solve for two problems. You will say, okay, k is 1, so you will look for I to k minus 2, and here another problem will be k plus 2 to j. Okay, same here. So I is what? K is 1. So when k is 1, the I is between 1 and 5. So 1, 2, okay, it will be 1, and 1 minus k is 1. If you are taking k also 1, then 1 minus 2 minus 1. Okay, another right solution will be, it's for it would be uh, k is 1, 1 plus 2 3, and j is 5. Okay, another option, so definitely for it you will can return directly true. From here you will get true because it's already overflow. I mean it's out of the range, so you can say assume it will be always gonna return true. Now this is the another condition where 3 and 5, so still it's in the range, so between 3 and 5 you can check. Again you will say, okay, I is 3 and j is uh, I is 3, j is 5. Now you will say, okay, now I need to choose between 3 and 5. So either 3 or 3 plus 2 5. You have two options. So let's say you choose 3. You choose 3, then you will be having I 3 to j k minus 2. So I minus 2, I mean k is 3, k is 3, then 3 minus 2, uh, k minus 2, 3 minus 2 1. Okay, so again it's like here it is bigger than this, so true. So that's how we need to solve it, and I don't think I will be able to do it complete. Oh god. So now let me write the solution for it. Function, and here I will be having I, j, that are representing the boundary conditions. And what else do I need to? I need a string or expression, you can say. If I greater than j, return true. Hey, I forgot one thing. If you are returning true, we need to return the output, right? Hmm. I greater than j returns true. Return. Hmm. If I have to just evaluate true or false. Then it's okay. But, bro. Okay. I just I'm thinking I can give two variables, but that is not right approach. I believe we can solve it with single variable. What I'm thinking, one. Let's return one. Imagine we are returning one here. That means this is a one valid solution. I got you already passed or you already exhausted all the you already exhausted all the values. That means it's so one of the possible option, right? And now what I'll do, so for a particular, let's say for k in range I and j plus 1, and I will do 2. So here plus 2, I mean. Now what I'll do, k, whatever k we are picking, that means we need to solve for that particular option, and I need to get the result from both sides, whether I'm able to do it for particular expression or not. Hmm. So what I'll do, simply here I will say, let's assume, so for particular k I will say, okay, these are two expressions, solve it and solve it. So if someone is returning false, okay, or someone is returning true, how will I get to know? If it is returning count greater than 0, that means okay, from this expression we are getting true, otherwise from this expression we are getting true, and now we can decide based on it. If so, I'll do simply one thing, left is equals to solve a function, whatever you said, function. Here I'll do one thing, I will keep a I and k minus 2, and another one right equals to function and k plus 1 2 into j. So I just got this. I will ask it simply to provide me the result for left part, right part, and I will decide based on if k equals to, there are other different characters, right? So and then I will decide k equals to or, that means another character, else, that means it's a zor. I mean, you can say, I'm writing comment. Now if k equals to and, if left greater than 0 and right greater than 0, so let's say from here you getting three approaches to solve it, and here you got something, so you are able to make solution out of it, and here you got two approaches. So how many different approaches are there total? Three different methods you followed, and you are just doing this, and different two methods. So can I say this is one option, this is one option, I mean 3 to the 6. So I will say if right greater than 0, then written left into right, else also it's else part also. If you are getting 0 from somewhere, then it will be 0 only, so no need to do anything. Oh, okay, okay, okay. Here if you see, so let's say you are getting 0, here you are getting 2. So what are the total approaches? I mean, whatever you are taking from here, hmm, here comes challenging. Here it's challenging. If it's or, one side I'm getting 0, another side I'm getting something. But what if there are different options, right? You can explore different things, and let's say you have something, some sort of, let's say A is or B or C, and here you said or, okay, and here you are getting something like two different options you have available, and from here you getting 0. Basically you are not able to make any approach. Here you can say, how much time I took? 28 minute band shoot guy. Can we solve it without without taking? Come on, man. Yeah, so I'm clueless or what? Here, if you see, now I have a confusion like whatever the different options are available in the wrong side, that are also possible combination, right? With the right approach. So, for example, you are getting true from the right right one, and from the left you are getting one false expression, and there is another false expression, there is another false expression, let's say three expression. But if you are returning 0, that means you will be getting 1. You are assuming there is only one possible combination, and now if I'll consider 2 from here, then it will be only 2. But if you notice, imagine something like here A is or B and C. Now here you can say A is or B and then and C, or you can say A XOR B and C first. Yeah, these are the only options, right? Now if I'll say or and here we have A or B, or maybe let's say P or Q, and here you are getting two options, or maybe let's say you are getting something from here. Let's say here it's three expression, and PQR. So PQR, let's say 2 you are getting from here, and different combination that you are getting here where you can get 2. Definitely those are going to contribute with this one. I mean, you can say, okay, if you are getting two combination out of this, and no matter what combination you are taking, these all are going to give you true results. So these are all different possible expression. Now it's getting challenging. If I will return 0 from here, that means I failed to get true expression from this one, and it means here I am getting two true expressions. When it comes to OR operation, it's not enough, but when it comes to AND, simply if nothing is matching you can return 0, that is acceptable. When something is matching, not matching, you can return 0, and if something is matching, then only those expressions should be considered in that scenario. At particular I, you will say, okay, solve this part. Not particular I, but particular K, you will say solve this part, solve this part. If both are true, then I will decide. Not both are true, maybe you are getting false from here, true from here. Now you will say or, whether it's and, whether it's jar, and based on that you can return true or false. So true or false. So far it is looking good. When it comes to next step, when I need to count all the possible options, or if it's and, simply whatever counts I'm getting from both ends, just I can multiply, because those are the different combination. And you are keeping key and you are solving this part first, then this part first, and then you are solving this part. If both are or. Okay, if or, then but what if I'll consider both sides, like it returning the flag true or false with the count. So let's say here I'm getting 3 counts, and false. Here I'm getting 2 counts with true. So when it comes to 3 to the 6, 6 count false. I can say 6 different options, because from 3A, and when you are keeping it somewhere and all these different options and this is different, you can say true and false 6. So if I'll return two things, true or false and value, then believe I can solve it. Oh, no solution for it. Use recursion to consider every operator in expression as a potential split point. I got it that one side is true. True if exactly one side is true. Operation as a main split. Yeah, I know that. Left true, left false, left. Uh, okay. Number of truths, number of false. 3 Zor. What is true, bro? Okay. What if I will calculate like number of true? I'm just returning true from an expression. Let's say I have something and or two operands before it. So you are at k, and now you know you have I, you have z. So you can calculate how many operands will be there. I minus, you can say k minus 2 minus I. So what it will do? So these are nothing but No, no, no. Count operators. Count number of operands. If I'll count, then I can say, okay, if there are three operands, then total possible ways are 3 twos are 3 into 2. All the possible options, like you can say one operator, or and and let's say 3. Then you can say, okay, you are taking this one first, or you will take this one, or you will take this one, and then whatever you are taking, so let's say you took this, then you have two options to take this one or this one first, this one then, or this one. 6. I'm sticking at each problem. Time pressure 46 minutes, no solution. God, even after watching the, I don't want to see the code. I got the intuition what needs to be done, but not able to derive the solution. If True or I mean I misunderstood one more thing I believe. True and F XOR true. Now if you are taking this one, then you will say okay solve for this part. I and j, and you will say okay solve for this I and j. Now you will solve for this. Then I is this location. So at any expression like at any k, you can say k minus 1, k plus 1, and based on that you will decide the result for it. Only challenging piece is Bancho. Sorry. If I'll take this as 0, is this one as no 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 no. Use recursion to consider every operator in expression as a potential split. For each split recursively compute the number of ways the left and right sub-expressions evaluate true and false. Combine these counts accordingly according to the operator. So use memoization to store result of first sub-expression I and j to avoid redundant computation. Hey bro, optimize. completely off. What is the use of is true? बहनचो मुझे क्यों नहीं समझ में आ रहा. Lift falls. It's like you are calling recursion twice. But why? Do we need? But why would I call? Between I and j. So let's say I, let's say j. These are two things. So can't I calculate the I and j and operator, or I and j and total uh, operands between I and j? It will be I plus 2, I plus 4 and till j. J. My. mm, A plus n minus 1 into t equals to j. So let's say 1 plus n minus 1 into d. D is 2 equals to j. So and j you can get it j. So j minus 1 by 2 plus 1 n. So if j is 7, 7 minus 1 by 2 plus 1 n, 6 by 2 plus 1, 6 by 2 3 plus 1, 3 plus 1 4. So if we talk about 7, that means there are 4 numbers, and 4 means 4 operators, and 4 operators means 4 factorial 4 operations. Correct. Memo key, and you are storing the value. How can you expect this type of solution? भैंचो बाल मेरे छिड़ जा रहे हैं. Or I'm struggling to solve simple problems. Let me try what I'm thinking, the approach that I'm thinking. So define solve, and here I will use ij, self I and j, and another thing is we have a string, and what I'll do, simply if I equals to j, I will return true only. So if I equals to j, that means we only have one operand. So then just we need to calculate if s of I equals to or, and s of I minus 1 equals to t, okay. So this is one condition where both are or. Return, simply what we can return, s of I minus 1 equals to t, and s of I plus 1 equals to false. If not both are false, that means you can say okay, this is one condition where both are false. So I am going to do one thing, not. That means if this is not the condition, then what will say, if both are false, then that means 0, and that means false, true, and opposite will be false. I mean, it will be true and its opposite will be false. So if this is not the condition, okay. So this is one condition where both are false, then only it will be 0, otherwise it will be 1, what I'm expecting. el if s of I, I'm just trying to explore, equals to and int. If both are true, then only it will be true. So I will copy the same and I will change the value here. Okay, if both are true, then you will get 1, otherwise you will get false. Here I forgot one thing. Definitely it's like you have to do not only. I get confused very quickly. So yeah, I get confused very quickly. So yeah, this is else part, that means return when either of them is true, int s of I minus 1 equals to true, and s of I plus equals to false, or s of I minus 1 equals to false, and s of I plus 1 equals to true. So if any one of these condition is true, satisfying, that means okay. So this is one thing. So if I equals to j, so this is base condition. Other than that, now we need to check about other conditions. So I'll say simply for k in range I to j plus 1 and plus 2, because every time what we are going to do, we are just trying out different operators. So what we'll do, so left will be the result of left, so you will say self dot solve, and here whatever you are going to get I and k minus 2, and s another one right is self dot solve I k plus 2, no, k plus 2, and j s. So these are the left and right. Now the next thing is, you got the left, you got the right, so you have number of truths at the left and number of truths at the right. So you can say left true and right true. Okay, now you want to calculate left false, right false. Fact, I'm just using self, not self, fact, self and n. So you will return So now I will ask it simply to give me factorial. Factorial left, you say simply between I and k. I and k. What if I and k are k minus 2? Oh god, it's not working, bro. I mean, I need to take break. Fuck, not able to solve problems.